Point 2 is on the Kaplan-Meier Survival Analysis. And survival analysis is defined by a couple of key terminologies. Survival time is the time lapse from the beginning of the observation to the time of a terminating event. A survivor, depending on the situation, could have various meanings, but we'll just generally call a survivor a subject that successfully lasted through a particular time period. The Kaplan-Meier method, or product limit method, describes survival behavior for some specific event based on varying survival time intervals for the terminating event being analyzed. The censored data is a survival times if the subjects survive past the end of the study, or if they are dropped from the study for reasons not related to the terminating event being studied. So, for example, let's consider an experimental medication tested with 5 smokers recruited for a smoking cessation clinical trial, where surviving means that the patient has not resumed smoking. The first patient disliked the taste of the medication and dropped out of the study on the first day, so the data from this patient are censored, as you can see in the top. Despite using the medication as directed, the remaining 4 patients resumed smoking after 3, 4, 7, and 21 days, respectively. And as you can see, this is the table corresponding to this. So the censored data, the first row of data represents the subject who dropped out of the program, and the 0 in the first row is the code for the censored data. So right here. Note that except for the entry of 0, the other columns in the row are empty. Removing the patient who dropped out does not affect the subsequent calculations except for the reduction in the number of remaining survivors. The second row of the data, so starting here with 1 day, here being number 3 here. The number 3 in this first column of the second row indicates that this patient resumed smoking 3 days after the start of the program. This patient survived for 3 days. The 1 in the second column is a code indicating that smoking was resumed. The 4 in the third column shows 4 patients remaining in the program. The 3 in the fourth column represents the number of remaining patients who have survived in the sense that they are not smoking. The proportion of 3/4 in the fifth column shows that 3 out of 4 patients have survived, as in not smoking. The proportion of 0.75 in the sixth column is the same proportion of 0.75 from the fifth column, but for the remaining rows. The proportion is the sixth column that will be the product of the proportion from the fifth column and any preceding proportions in the fifth column. The sixth column of cumulative proportions of survivors. The first entry of 0.75 is the same proportion from the fifth column. Second entry of 0.5 is the product of 0.667 times from the fifth column and the preceding entry of 0.75 in the fifth column. So we get 0.667 times 0.75 equals 0.5. Third entry of 0.25 is the product of 0.5 from the fifth column and the preceding entries of 0.667 and 0.75 from the fifth column. When we multiply all those, 0.5 times 0.667 times 0.75, we get 0.25. The fourth entry of 0, the product of 0 from the fifth column and the preceding entries in the fifth column, we get 0 times 0.5 times 0.667 times 0.75. And since we multiply by 0, as you could expect, we get a value of 0. For my second example, we have the preceding example 1 describes survival for 5 patients who were treated with medication. In the same program, let's say 10 different patients underwent counseling in an attempt to stop smoking. The results from these patients are summarized in table 14.4, so that's one. This counseling program was discontinued after 28 days. Table 14.4 is an example of survival data with Kaplan-Meier calculations. Note that in table 14.4, the number of patients decreases when patients are censored, as indicated by 0 in column 2. And then this last example, an interesting and revealing as tables 14.3 and 14.4 are, It is usually more helpful to construct graphs that make it easier to understand the survivor data. So see the accompanying Kaplan-Meier accumulative survival curves in figure 14.1 down here that incorporates the survivor data from table 14.3 and 14.4. The graph is constructed by using the survival times, column 1, and the cumulative proportions of patients not smoking, column 6, from tables 14.3 and 14.4. The Kaplan-Meier cumulative survival curves in figure 14.1 show that the proportions of survivors, patients who have not resumed smoking, with counseling are generally higher than the proportions of smokers with medication. So it becomes clear that the counseling program had better results than the medication program. However, neither of the programs had very high rates of survivors, so neither program appears to be very effective in helping patients achieve success in their attempts to stop smoking. And as you could assume, we can make these types of graphs in SAS. Let me know if you have any questions or concerns. Thank you.